Good morning and welcome. My name is Candice Patton, and I'm the Executive Director for Clean Technology at Alberta Innovates. I am so excited to bring you the first session in our Small Modular Reactors Learn How series. Alberta Innovates is the innovation engine for the province of Alberta. When a new technology has the potential to benefit Alberta, our teams get excited to explore the opportunities and challenges that those technologies may present. We love to share knowledge, open up connections for good conversation around energy and clean tech. So we hope this series is going to spark ideas for you. Alberta Innovates is a member of the Action Plan for Small Modular Reactors. And if I can quote the vision, we're looking for small modular reactors to be a source of safe, clean, affordable energy, opening up opportunities for a resilient, low-carbon future and capturing benefits for Canada and Canadians. This series is an opportunity for Albertans to discover nuclear technology and to hear more about the Action Plan, safety and regulations, and innovation in Canada's nuclear industry. We've got 4 sessions over the next 4 weeks to share with you. Today is SMR 101, and I'm so pleased to welcome our speakers. Dianne Cameron for Natural Resources Canada, John Gorman, the President and CEO of the Canadian Nuclear Association, and Marcel DeVos from the Canadian Nuclear Safety Commission. Next week, in Session 2, we're going to feature voices from New Brunswick, Ontario, and Saskatchewan to talk about some of the exciting innovation happening around SMRs in Canada, lessons learned so far, and how provinces are coordinating to understand opportunities around these technologies. The 3rd session on March 2nd will feature Ron Oberth from the Organization of Canadian Nuclear Industries to talk about potential industrial opportunities for Alberta and a technology showcase featuring 9 companies with different SMR technologies, so you can learn a little bit about each one. Finally, our 4th session on March 9th will get into community engagement and conversations around energy transition. I hope you can join us for many more of these sessions. I've got a few housekeeping items before we kick off. We will be recording the webinar, and it will be available along with the presenter slides after the session. We want to hear from you as well, so please feel free to use the group chat to say hello, let us know where you're joining from, and I'd love to hear what drew you and what piqued your interest for the session today. During the presentations, if you've got a question for our speakers that you'd like me to ask them at the end, use the Q&A button at the bottom to submit a question. You can let me know who you want to direct your question to, or if you'd like, leave it open for the speakers to answer together. You can also use the Q&A if you need help with a technical question. Our comms team will be looking out for any issues you have. At the end, if we don't have time to get to your question, we will be capturing them all and give our speakers a chance afterwards to respond to them, and we'll post the responses with the presentation materials after. If you're not already using Google Chrome, that is the browser we recommend for the best viewing experience here. All right, let's dive into our first presentation from Dianne Cameron. Dianne Cameron is currently the Director of the Nuclear Energy Division at Natural Resources Canada. As Director, she heads up the division responsible for leading and coordinating Canadian public policy on nuclear energy. Ms. Cameron serves as the Chair of the Canadian Roadmap and Action Plan for Small Modular Reactors. She received a Master's in Technology and Policy from MIT, where she was named the Alfred Keil Fellow for Wiser Uses of Science and Technology. Ms. Cameron also holds a Bachelor of Applied Science and Systems Design Engineering from the University of Waterloo. So Dianne, I will pass the virtual mic over to you to start your presentation.
Thank you so much for the kind introduction, and hello, everybody. Thank you, Candice. I am Dianne Cameron. I'm the Director of the Nuclear Energy Division. And in this role, it is my distinct pleasure and privilege to oversee the team that leads and convenes nuclear energy policy for Canada, in close collaboration with provinces and territories, including Alberta, and utilities, as well as industry, and increasingly in conversation with heavy industry stakeholders like mining and oil sands and civil society, of course, in an ongoing and respectful discussion with Indigenous peoples across Canada. Next slide, please, to slide number 2. I'm going to structure my talk today in 3 parts. I'm going to start with a bit of context on Canada's climate change policies before turning to nuclear energy in Canada broadly, and then honing in and focusing on small modular reactors. Next slide, please. So here I'd like to start out with a little bit of context about Canada's climate change policy framework and our objectives on climate change. In 2020, the Government of Canada released its Strengthened Climate Plan. This built on the momentum of the 2016 Pan-Canadian Framework on Clean Growth and Climate Change, and our original commitments that we made in 2015 under the Paris Agreement to reduce emissions. The Strengthened Climate Plan, released in 2020, invests an additional $15 billion in clean energy investments and puts a higher price on carbon, rising to $170 per ton of carbon dioxide by 2030. The strengthened plan is supported by a strong policy framework, and that includes a variety of individual pillars and initiatives, including the new Clean Fuel Standard, a hydrogen strategy for Canada that includes an aspect on nuclear hydrogen, and also Canada's new Small Modular Reactor Action Plan, which we'll be talking about later today. Turning to the next slide, please. Just to drive home this climate change context for our discussion, I'd like to highlight a report that was released by the International Energy Agency in 2019. The International Energy Agency is a body of the OECD. It's an international organization. It's one of the highest level international think tanks, if you will, in one sense, that does analysis and provides advice and provides the evidence base on climate change and clean energy for policymakers at the highest level around the world. And the International Energy Agency, the IEA, released its first report on nuclear energy in 2019, first report in over 20 years. This was a ground-moving report for us. It really brought home and raised the profile of some key analysis, and I'd like to highlight two key conclusions that it drew. And one of the conclusions is that the risk of failure, outright failure, for the world in our efforts to meet our climate change objectives is significantly higher if we attempt to do so without nuclear. But even if we were to succeed in meeting our emissions reductions targets and our 2-degree scenario objectives without nuclear, it would cost the world $1.6 trillion more to do so without nuclear than with nuclear, which is approximately the size of the Canadian economy, just to put that in perspective. So we know that nuclear has a vital role to play in addressing climate change. Turning to the next slide, I'd like to provide a bit of context now, an overview of nuclear in Canada. The first thing to note is that Canada is really good at nuclear. Not many Canadians know this. We were the second country to achieve the ability of criticality, which is this key step in actually generating nuclear energy. We were the first country to declare that we would use nuclear only for peaceful purposes. Approximately 1/4 of our Nobel Prizes in Canada are related to nuclear science. We are one of a very small and very elite group of countries, only 8 in the world, with the type of capabilities that we have in Canada in nuclear. We're the world's second largest producer of uranium, and we provide from our nuclear power plants more than half of the world's supply of a radioisotope called cobalt-60, which is used in cancer treatment, and it's also been critical in the pandemic response because it is used in the sterilization of medical equipment like PPE. Turning to the next slide. From the perspective of the federal government of Canada, nuclear is more than just one of several options for generating non-emitting electricity. A critical and strategic asset. We have a pan-Canadian industry from which we derive significant economic, geopolitical, public health, and environmental benefits. The nuclear sector in Canada contributes $17 billion in GDP and supports 76,000 jobs. There are over 200 small and medium-sized enterprises in the Canadian nuclear supply chain. Nuclear supplies about 15% of Canada's electricity. I already mentioned that our nuclear power plants produce medical isotopes. Nuclear in Canada offsets over 50 million tons of carbon dioxide every year. It's absolutely essential for our climate plan and to reach our Paris targets. It is also a beachhead for strategic international engagement from a geopolitical perspective. Turning to the next slide. Now I'd like to come to the topic of the day, which is a really exciting topic, small modular reactors. But before I go any farther, let me just quickly take a moment to define what it is that we're talking about when we say SMR, small modular reactor. Just as the name implies, they are smaller both in terms of physical size and in terms of power output than the CANDU reactors that we already operate in Canada today. They're modular, which means they're meant to be factory produced. And the modularization of that construction process, bringing things from stick building construction into a manufacturing modularization using the benefits of additive manufacturing, advanced manufacturing, those are some of the ways that the industry intends to drive down the costs. They're also modular in the sense that they're stackable or scalable. So if you had a small modular reactor that was maybe 5 megawatts electric in size, the kind of unit that would fit, that would roll off of a production line, just like we manufacture pickup trucks, and then we'd ship them to site, or we truck them, or put them on a train, or put them on a barge. We would do the same thing with these small modular reactors, deliver them to site. If you had a mine site, for example, or a heavy resource site that needed, let's say, 30 megawatts electric power, and you had these 5 megawatt electric units, well, you could deploy 6 of them, or you could actually deploy 7 or 8 or even 9 of them, create some redundancy in your own system, which could allow you, if you're off grid, not only to phase out your primary diesel, but also potentially your backup diesel. They are reactors, so small and modular and reactors. By reactor, what we mean is that somewhere at the middle of these things, there is a nuclear fission reaction that is generating heat. So nuclear fission is the process at the atomic level of splitting the atom, which is that criticality I talked about, where Canada was the second country in the world to figure out how to do that. So nuclear fission creates heat, and we can use the heat directly as process heat in industrial applications. We can use the heat for district heating or for desalination or to produce hydrogen. There's lots of ways to use the heat directly, or you can use the heat, and if you want, to generate electricity. So a couple key points here. So an SMR technically is defined as anything that produces less than 300 megawatts electric. A current CANDU reactor, the kind we have in Canada and Ontario and New Brunswick, it's a gigawatt scale reactor, so on the order of 1,000 megawatts electric. So an SMR is anything less than a third that size. But even within that range, there's a range of sizes, which we're going to unpack in a little while. For anywhere from 300 megawatts electric, it gets a bit silly because we start talking about large small modular reactors, down to very small modular reactors in that 5 scale. So it's sort of like vehicles where, if you say, I need to buy a vehicle, that's not specific enough. You could be talking about a motorcycle, you could be talking about a pickup truck, you could be talking about a semi. And so same thing with SMRs. It's still a pretty big category. Turning to the next slide. This is one of my favorite slides. This is artwork that was commissioned by an environmental NGO called Third Way, which is based out of Washington, D.C., and they hire, and we have permission to use their artwork. They asked an artist to imagine and to depict what SMRs might look like as they are deployed into these new applications and new settings. And so because they are smaller, they're more modular, and they're going to be able to break into new applications and new markets and new contexts that large nuclear was never able to support. And so what's shown here, top left-hand corner, is a data center. So we are all increasingly running our lives off of the digital economy, phones, telework, and the data centers that are the backbone of that digital economy are power hungry, and they require an enormous amount of electricity. And when those data centers are located in jurisdictions like California that still burn coal, that has a significant impact on climate. So what the artist is imagining here is that a data center is powered by a combination of SMRs and wind. When the wind is blowing, the wind electricity is being used, and when the wind isn't blowing, the The SMRs are dynamically load following and providing the power needed for that data center, making a significant impact on emissions reductions. Bottom left-hand corner. Personally, my least favorite picture, but still a very important concept. It's visually not as appealing, but it's a very important concept. This is an SMR for heavy industry. So this is exactly the scenario we were just talking about. Any heavy industry application that requires high temperature. We all know that it's very inefficient and very expensive to turn electricity back into heat, which is why there's a market for natural gas cogeneration, combined heat and power. In industries like steel, like cement, like pulp and paper, like SAGD in the oil sands, where you need that high temperature heat. And so SMRs are really the only emerging technology that promises to provide, or has the potential to provide, a non-emitting cogen solution to compete with natural gas, which is going to open up these new parts, get us access to these otherwise hard to abate parts of the economy. Top right-hand corner, a micro SMR in a remote northern community, providing not only electricity, but providing district heating and heating for a greenhouse to increase food security. They can run a greenhouse year-round, fresh tomatoes year-round, that kind of a thing. Bottom right-hand corner is an energy park. The idea that's illustrated here is the idea of tightly coupling a variety of different technologies like geothermal, wind, and solar with SMRs, having them dynamically linked so that when the wind is blowing and the sun is shining, that's where you're deriving your electricity from. You're using pumped hydro power as a blue battery to save the electricity from your SMR when the wind is blowing. When the wind is not blowing, you're using your SMR, you're drawing down your blue hydrogen, and you're using that for a variety of purposes. Desalination, irrigation, electricity, and you're creating a lush environment for people. Turning to the next slide. So turning from sort of nuclear in the imagination to nuclear here in reality in Canada. Through analysis and market analysis and stakeholder engagement, we've identified 3 discrete markets for SMRs in Canada, ranging from, at the left-hand side, at the large end of the spectrum, coal replacement, basically. These are SMRs that are at the large end of that scale, 300 megawatts electric, replacing coal and generating electricity on a grid. The main value proposition is electricity on a grid. At the other end of the spectrum, remote communities. Here we're talking about units that are on the order of 2 to 5 megawatts electric. And there's demand there for the over 200 communities in Canada that currently rely almost 100% on diesel and are looking for alternatives to replace diesel. There are some communities in Canada that are interested in including SMRs in their decision-making as a viable alternative to diesel. And then in the middle is probably the sweet spot for Canada, a niche that we can really step into because we are both a world-leading nuclear power, but we're also a resource extraction and resource processing superpower. And so here we're talking about that cogen, combined heat and power for heavy industry applications. Turning to the next slide. This is a slide from Canada's SMR roadmap in 2018, where we did an analysis of the size of the domestic market. Again, that combination of grid scale for electricity, remote communities, and also heavy industry. And we estimate that the size of the market will yield up to $19 billion in total annual economic impact between 2030 and 2040, creating about 6,000 new jobs per year. Next slide, please. And the international market is estimated to be gigantic, reaching over $150 to $300 billion per year by 2040. Now turning to slide 12. Some of you may already be familiar with Canada's SMR roadmap. It was a project we undertook in 2018, and it is the focal point for the development of Canada's SMR strategic policy framework. A pan-Canadian team oversaw expert analysis, technical workshops, and engagement sessions across the country to produce the evidence base that would inform our vision and our approach to SMRs in Canada. Turning to the next slide, and now coming to Canada's SMR Action Plan. In 2020, we took the next step. We reconvened a pan-Canadian initiative to build to develop Canada's SMR action plan, building on the momentum of the roadmap, where the roadmap articulated a vision. That's the what we want to achieve. The action plan sets out the guiding principles, how we want to achieve the vision. Where the roadmap set out 53 recommendations for action, the action plan responded to all those recommendations with nearly 500 commitments for action that go well beyond the original recommendations of the roadmap. Where the roadmap initiated Indigenous engagement and dialogue, in the action plan we commit, and as do other partners, we commit to a continued meaningful ongoing engagement. In 2018, 55 organizations across Canada contributed to the roadmap. Turning to the next slide, you can see that in the action plan, over 110 partners joined us in the action plan from across Canada, from Alberta, Saskatchewan, Manitoba, Ontario, New Brunswick, PEI, the Yukon, and Nunavut, including federal, provincial, territorial, and municipal governments, Indigenous partners, industry, and civil society. All of Canada's action plan partners endorsed the vision, committed to the principles, and are taking action to turn our roadmap vision into reality. Turning to the next slide, and this will be my last slide, our vision situates SMRs within the broader national priorities on climate change, but also on innovation, and also on climate change. I already said climate change, but good jobs and economic recovery. So please check out our SMR action plan at smractionplan.ca. Our vision, and we hope that you agree, is to develop and deploy SMRs in Canada as a safe source of clean, affordable energy, opening opportunities for a resilient, low-carbon future, and capturing benefits for Canada and Canadians. And in the interest of time, I'll share with you the slide on the 3 streams, and we can address that in Q&A. But I'd like to conclude now by just thanking you and looking forward to the day.
Thank you so much, Dianne. I've been seeing the questions coming in from the audience, and we're going to have some time at the end to answer them. So if you've got more questions for Dianne, please keep sending them in using the Q&A box below. There have been a few questions coming in about the slides and the presentation. The webinar is being recorded and will be available after the session, as will the slides. And if we don't get to your question today, we'll also give the speakers a chance to answer it after the program and post those as well. Our next speaker, John Gorman, is the President and CEO of the Canadian Nuclear Association. Prior to joining the CNA, John served as President and CEO of the Canadian Solar Industries Association, CanSIA, the National Trade Association for Canada's solar energy industries. John serves as Canada's designate to the International Energy Agency and sits on the executive of the Canadian Council on Renewable Energy. John's been recognized as one of Canada's Clean 50 and is the recipient of the 40 Under 40 Business Award for Excellence in Business Practices. He was also awarded the designation of Climate Project Ambassador by Nobel laureate Al Gore in 2008. John, we're looking forward to hearing more about SMR opportunities for Alberta from you now.
Thank you very much, Candice. And thanks to Alberta Innovates for putting together such an interesting set or series of webinars. We're really excited to be a part of this. I'd also like to give a shout out to Dianne Cameron, who has been such a champion for nuclear in Canada and in particular of small modular reactors, and for that presentation, which really laid out so many of the fundamental aspects of small modular reactors. And that's going to allow me to be fairly brief on those pieces and hopefully focus a bit on the Alberta market and uses in the Alberta sector. So, Candice, why don't we go ahead to the first slide? Small modular reactors. Dianne covered this really well, right? You can think of these small modular reactors almost as personal computers, distributed computing compared to mainframe computers. For those of you who remember the mainframe computers, I mean the conventional nuclear plants produce vast amounts of clean electricity, and they are major infrastructure projects, right? For example, right now we are refurbishing the nuclear plants in Ontario. It's a $26 billion infrastructure project that takes place over 10 years. It is proceeding on time and on budget. It's going to ensure that Ontario continues to meet about 2/3 of its electricity needs well into the 2060s. In a very cost competitive way, right? It's the second cheapest form of electricity in Ontario, and it will continue to be so. And it comes in at about 2/3 of the cost of residential electricity. So very cost effective, these conventional plants. And in the case of Canada, these conventional nuclear plants enabled Ontario to replace about 90% of its coal. And that is still the world's largest decarbonization initiative. So conventional nuclear is a good thing, a big, large infrastructure project where these small modular reactors are very modular and distributable. And the other thing I'll say that Dianne didn't focus on too much is they're also very responsive. So they are able to play very well with intermittent sources of electricity like wind and solar that need to be supported by something as a base load. And small modular reactors, like gas plants, are able to ramp up and ramp down quite quickly, and that makes them a good partner for renewables. Next slide. So one of the remarkable things about small modular reactors, and as Candace said in the beginning, I come to nuclear from the renewables side. I've been here for about 1.5 years, and something I didn't fully appreciate about small modular reactors is that they are not just a form of electricity that is very scalable in terms of how much electricity you want, but they are a form of very high temperature clean heat. And it's on the basis of this clean heat that we're able to do a variety of things. Dianne mentions some of them. You could desalinate water, for example, which is so important in some regions of the world. But in the Canadian context, you're using that very high temperature heat to produce electricity, primarily through steam, or else you're producing very, very high temperature steam that can be used in extraction industries, like the oil sands, for example, or could be used to produce heat in a mining situation as well as electricity. And of course, you could use either the electricity or the high temperature heat to produce hydrogen. So you have these very scalable small modular reactors that can be small enough to be providing electricity and heat to a small northern community, or large enough to be attached to an electricity grid producing 300 megawatts of electricity, and at the same time be using the heat to do other things like produce hydrogen, etc. So very, very flexible, almost a tri-generation type technology that we can use in the Canadian economy to help decarbonize some of those places that are some of those industries that are difficult to decarbonize, whether it's cement or steel or oil sands or mining operations, etc. Next slide. So one thing I'd like to spend a little bit of time focusing on is Canada's expertise in this area and the opportunity that we have right now as a nation and that Alberta has to be a first mover in small modular reactors, to use the technology in regions across Canada to meet the various needs of our economy. It's about a $5.3 billion market just domestically here for small modular reactors. But these provinces of Alberta, Saskatchewan, Ontario, and New Brunswick, these 4 provinces, the premiers of which have signed an MOU about the development and deployment of small modular reactors, these 4 provinces, including Alberta, really have the opportunity to participate in this sector, both domestically and internationally. And as Dianne pointed out, that market internationally for the deployment of small modular reactors is enormous, right? It's going to be somewhere between 150 and $300 billion a year by the time we hit the late 2030s. So a big prize there. Now, why is Canada in a position to be a first mover with small modular reactors? For some of the reasons that Dianne mentioned. Of course, we've got a long history in nuclear. We're a tier 1 nuclear nation. We've been operating plants successfully for over 60 years. Right now, they provide 2/3 of the electricity in Ontario, 1/3 of the electricity in New Brunswick. Of course, we've got an amazing uranium industry here. We're the second largest exporter of uranium in the world, primarily in Saskatchewan. Right now, we've got a top-tier nuclear laboratory, the Canadian Nuclear Laboratory, and we're a leader in medical uses of nuclear as well, like isotopes, for example. It's this whole ecosystem. And interestingly, we also have a competitive advantage in our regulator. Our regulator is uniquely suited to be able to deal with innovative technologies like these small modular reactors. So we have a speaker coming up, of course, who's going to be able to speak to this. But whereas there are some regulators in the US, for example, who might look at a technology in a very prescriptive way. So look at a new innovative technology from one of these companies you see on the screen here, for example, and say, well, you have to do it this way. Whereas our regulator is more able to say, show us how your technology is going to be able to clear this particular hurdle. And that allows for good innovation. And it's the reason that we have 12 different SMR technologies going through the review and licensing process right now. So I'd say the CNSC, our regulator, is a competitive advantage. I'll just say one more thing. Dianne spoke about the leadership of the federal government on this, the SMR roadmap, the SMR action plan, which, of course, Alberta Innovates signed on to. These things have been very, very important for making industry and the rest of the sector join together and have a very coordinated approach to rolling out these small modular reactors. As a result, we have 4 major utilities now in Canada that have agreed to a plan for the development and deployment of these small modular reactors. We have the federal government now firmly taking the position that nuclear is needed for our future and clean, and is committed to working with the provinces and the premiers of Alberta, Ontario, New Brunswick, and Saskatchewan to make this a reality. So things are looking very positive for Canada as a first mover right now. And of course, Alberta being in that mix means that if you start using the expertise and innovative approaches that you have, as well as your various sectors like oil and gas where these things can be applied, not only could you be making a more competitive product going into the future from a carbon point of view, but developing that expertise that can help other nations. Next slide, please. This plan that we have for the utilities and the industry rolling out small modular reactors, we've broken it into 3 streams. The first stream is sort of the larger 300 megawatt reactor, which is going to be connected. Ontario Power Generation has said that it will connect it by 2028. Saskatchewan has commented publicly that it's going to follow with the same technology right behind Ontario to introduce small modular reactors by 2030, thereby allowing for coal to be phased out and less gas plants to be built and more renewables to come online. We have another stream which is even more advanced reactors than this, which will be available a little bit later, and then a third stream in the plan that is the smaller small modular reactors, which can be used for off-grid applications such as mining, oil sands, remote communities even. Next slide. So why is Alberta interested? Well, Minister Savage and Premier Kenney, of course, have primarily been talking about small modular reactors and their application to the oil sands operations. I think Premier Kenney has said that, if we're going to see the use of oil diminish over the years because of carbon constraints, we want to see Alberta have been producing that last most competitive barrel of oil, and certainly small modular reactors and the very high temperature heat and steam can help the sector do that. We've been doing some research that has shown a really terrific adoption and potential in the oil sands because of the options that are available and for costs. Next slide. So the opportunity for Alberta, of course, goes beyond just creating more competitive oil in a carbon-constrained world, but an opportunity to use this long history of energy development that Alberta has. Its expertise in innovation, the respect that it has globally for its research sector, its educated and skilled workforce. These things can all be applied to the nuclear sector, the small modular reactor sector, to bring a new dimension of jobs and economic benefit to Alberta. I'd also say that you share with Saskatchewan the Athabasca Basin, which is, I think, the largest uranium deposit in the world. And so there's a great potential there to expand the mining sector within Alberta. So these first movers in Canada, along with Canada's first mover advantage, means that these provinces, including Alberta, will be able to create new jobs and high-tech innovations and export opportunities for SMRs around the world. I'm really pretty excited about Alberta's prospect of being able to roll these things out, deploy them in places like oil sands, and then be able to extend that expertise to other nations and help them. Next slide. So I think we've spoken about, I've spoken about this, just how the high temperature heat can be used and how scalable they are to ensure that they can be used to decarbonize every barrel of oil. But of course, there's the creation of electricity at the same time, and hydrogen, which is an exciting prospect for Alberta. Next slide. So we know that there are applications in northern and off-grid remote communities as well. Communities like Lacrete and Buffalo Head Prairie, Paddle Prairie, Keg River, etc., that have to suffer routine natural gas shortages in the winter months. So there's some terrific opportunities there in northern Alberta as well. Last slide, please. So I just wanted to emphasize this point about hydrogen. Alberta, the Alberta government has been quite clear that it wants to be a leader in the production of hydrogen going forward, not only for its own economy, but for the export potential and to be able to supply hydrogen domestically. You've got some great gas assets right now that can help do that. Small modular reactors are going to be able to add to that potential. And as I said, do it in a way where it's not just being created to produce hydrogen, but perhaps be helping with high temperature steam and the oil and gas extraction, at the same time producing hydrogen and off cycles and electricity for all your needs. So you can use this clean nuclear to be able to produce hydrogen and have Alberta really meet its expectations and targets in terms of being a powerhouse in Canada for producing cost-effective clean hydrogen. So that's it for me, Candice.
Thank you so much, John. So appreciated. We've got questions flying in, so there's going to be lots of other material for you and Dianne and Marcel to chew on at the end here. And just a reminder for those folks, we are recording the webinar and we will have the opportunity to answer questions that we don't get to today and provide them to you following the session. So now I'd love to introduce our final speaker for today, Marcel DeVos. Marcel works for the Canadian Nuclear Safety Commission as a licensing project officer for almost 15 years and has been exclusively involved in regulatory readiness for new build nuclear projects in Canada. He works within a team of specialists to study and address both technical and regulatory perspectives about SMR technologies in Canada nationally for more than 10 years and regularly contributes to the work of the International Atomic Energy Agency. Marcel is here today to give an overview of the CNSC to assure Canadians that any SMR projects in Canada will continue to meet the high standards of safety. accepted in the public. So Marcel, I'll pass you the virtual mic for your presentation.
Good morning, everyone, and thank you very much for the opportunity to speak today. As Candace mentioned in her introduction, I'm here today to introduce you to Canada's nuclear safety regulator. The potential introduction of small modular reactor technologies and projects to Canada falls within our regulatory mandate. So I'm going to explain to you how we have readied ourselves to regulate over the past several years. Just checking to see if the slide is progressing. Candace, can you do the slide changes for me, please? The regulation of nuclear activities is a national responsibility, and our role covers all regulated activities from mining to waste management over their full project lifecycle. In Alberta, the current most common types of licensees range from medical diagnostic and treatment applications to oil well logging and radiography used to ensure that, for example, welds and piping systems are of the highest quality. We also regulate the transport of nuclear substances and how sensitive technical information or technologies, which we call prescribed information, are exported. Next slide. Canada's nuclear regulator has been around in some form since 1946 and has continuously evolved not only with industry growth, but also with changing societal expectations of what a regulator should do. Our mandate is to regulate the use of nuclear energy and materials to protect health, safety, and, of course, security in the environment. 2, using nuclear energy for peaceful purposes only, and we must demonstrate this on the world stage. The CNSC has a role to disseminate objective, scientific, technical, and regulatory information to stakeholders such as the public. This is a major part of our regulatory processes and day-to-day work. But there are some things that are certainly not part of our mandate. We do not promote the use of nuclear energy. Our role is to regulate whatever is proposed to be done in Canada. The CNSC does not select locations for potential nuclear activities, and we do not select technologies to be used in licensed activities. The CNSC does not participate in provincial and federal government energy policy, such as what types or mix of energy to use, or in provincial and federal government waste policies. And Indigenous engagement and consultation are part of our mandate, and they're a large part of our mandate, but we are not responsible for Indigenous rights and treaty determination. Next slide. The CNSC's regulatory approach is focused on safety, security, and environmental protection, and is aligned with fundamental regulatory and safety principles established by the International Atomic Energy Agency, or IAEA. The IAEA conducts missions on a periodic basis to various countries, such as Canada, to confirm that Canada remains aligned, and those reports are posted. Under our framework, licensees are directly responsible for managing regulated activities in a manner that protects health, safety, security, and the environment, and that the work that they do conforms with Canada's domestic and international obligations on the peaceful use of nuclear energy. The CNSC is accountable to Parliament and to Canadians for assuring that these responsibilities are properly discharged. The CNSC therefore ensures that regulated parties are informed about requirements and are provided with guidance on how to meet them, and then verifies that all regulatory requirements are and continue to be met. Next slide, please. The Commission of the CNSC is an administrative tribunal established and governed under specific legislation called the Nuclear Safety and Control Act. This means that they are a decision-making body along the lines of a court. This also means that they're an agent of the Crown with a duty to consult. Each of the members you see in the slide are appointed by the Governor and Council and bring different experiences, skills, and societal perspectives to the table. This means that the body of evidence sitting before the Commission for a decision will be viewed through different lenses pertinent to nuclear safety. The Commission is an independent regulatory body, but is still responsible to Canadians. and therefore reports to Parliament, because reporting through the Office of the Minister of Natural Resources. But I would like to clarify the Commission does not report to the Minister. The conduct of hearings and meetings by the Commission are public and are webcast, and decisions are made by the Commission are reviewable by federal court. Next slide. Making these regulatory decisions involves weighing many complex factors. As a result, the Commission has established a body of dedicated professionals to provide them with timely advice. My colleagues and I are commonly called CNSC staff. We have no special access to the Commission. We are a separate organization who communicate with the Commission through the same mechanisms used by the public and industry. We're composed of dedicated persons with diverse expertise ranging from scientific and technical knowledge through regulatory policy, communications, and Indigenous consultation. When an application for a license is submitted, our role is to assess that application and make recommendations to the Commission to inform their decision-making. Once a license is granted, we verify compliance with the license and our regulations. For facilities such as nuclear power plants, we have dedicated inspectors who know and inspect those facilities for compliance. To maintain our expertise as technology and practice evolves, we execute regulatory research, and this helps us shape our approach to regulation in our requirements and guidance, which I'll speak to later. Next slide. On top of our headquarters in Ottawa, we have frontline staff located in 4 regional offices, including Calgary. Where there are major nuclear projects, such as the ones shown on the slide, we maintain site offices with dedicated inspectors. We have 3 site offices at Chalk River Nuclear Laboratories in Ontario, at the 3 nuclear power, we have site offices at the 3 nuclear power plant sites in Ontario, and at the New Brunswick power site called Point Lepreau Generating Station. Staff at our headquarters have a role to provide technical support, and they work with the regional and site inspectors to perform compliance activities. Next slide. One nuclear power plant site is the Darlington Nuclear Generating Station, which is located in the municipality of Clarington, east of Toronto. This station contains 4 domestically designed Canada Deuterium-Uranium, or CANDU reactors that have each been safely producing 875 electrical megawatts of clean energy since the early 1990s. To each reactor as a unit in our facilities. This station supplies approximately 20% of Ontario's electricity, and each unit is progressively undergoing long-term refurbishment activities to be able to continue 2055, changing components and upgrading systems with newer technologies to improve performance. Our regulatory role during refurbishment is to confirm that these upgrades are being conducted to a high degree of quality by the licensee, and there's an expectation that there will be an overall improvement in station safety performance. Next slide. CNSC staff have been looking at small modular reactors for years in order to maintain a state of readiness to regulate if they are ever proposed to be used in Canada. We recognize that such reactors may introduce new technologies and features, and that safety can be achieved in different ways. But under the Canadian regulatory framework, SMRs simply fit into a spectrum of all the other reactors that exist in Canada, from research reactors up to the large nuclear power plants. In other words, the term SMR has no official legal meaning. To understand how SMRs may be built or operated differently, we're currently in the process of actively reviewing 5 different designs under a technical feedback process called a vendor design review, which is performed before the licensing project for a project would ever proceed. There are other designs in the pipeline that will be reviewed once the vendors decide to proceed. As I will explain shortly, we do not license technologies in Canada. As a result, when we provide regulatory feedback to a reactor vendor, we cannot make regulatory decisions. Because there are no decisions being made, the Commission is not involved in these pre-licensing engagement activities. To give useful regulatory feedback and learn about these technologies, we use this vendor design review process to access vendors' proprietary information. Reactor technology, we post the overall results of the review on our website but we can divulge proprietary information. If one of these designs is referenced in a license application that is submitted to the Commission, then a formal licensing process will proceed and the Commission will make the licensing decision. Next slide. CNSC staff have noted that SMRs have many similarities with a number of the smaller reactors that have been built in the past all over the world, while recognizing that modern advancements are being proposed. For example, the first reactor facilities in the world were small, in the order of 100 to 300 megawatts electric in output per unit. These facilities were built on greenfield sites with very little infrastructure on them. And as a result, everything except the concrete was manufactured off-site and delivered by truck or barge to the location for assembly. In the photo on the left, we see the installation of the Calandria, which is a large reactor assembly, at the Douglas Point Generating Station in 1966. In modern terms, this would be referred to as a module. This first-of-a-kind 220 megawatt electric facility operated from 1967 until 1984 and demonstrated commercial grid-scale power generation in Canada for plants in the world to generate electricity commercially. In the photo on the right, the White Shell reactor, which is located in Manitoba, was an ingenious test and research concept that ran from 1965 to 1985, and it used an organic oil as a reactor coolant instead of water. In addition to materials testing over its lifetime, it was also used as a district heating system for the White Shell site. Next slide, please. In a more modern context, a company called Global First Power, or GFP, submitted a license application in March of 2019 for a license to prepare site for a reactor facility to be deployed on land at the Chalk River Laboratories in Ontario. According to GFP, the facility will provide either high-quality heat or up to 5 megawatts of electrical power. Global First Power is co-owned by Ontario utility Ontario Power Generation and the reactor vendor called Ultrasafe Nuclear Corporation, or USNC. This will be a full-scale commercial demonstration facility. Global First Power has indicated that it will be used to demonstrate the reactor concept, ability, gathering of technical experience, which learning with operating these plants is always a major concern, and supporting staff training and certification. The diagram in the slide shows a conceptual cutaway of the reactor building and only represents a portion of the whole facility. The intent of the final commercial design would be to provide continuous supply for 20 years to the site. The environmental assessment for this project is currently underway. This is an example of a potential design that could be used for mining or a very large community. Next slide. The existing nuclear utilities in Ontario have announced a number of initiatives in support of SMR deployment. At the Darlington New Nuclear Project site, just east of the existing Darlington Nuclear Generating Station, Ontario Power Generation holds a license to prepare site for the area that's indicated with an arrow in the diagram and is seeking to renew this license at a hearing in June of 2021. OPG announced last October that it is in the process of selecting potential grid-sized SMR technologies for this site and has down-selected 3 specific technologies, while still not closing the door to potential others. On December 2nd of last year, OPG informed the CNSC of its intent to submit a license to construct application by the end of March of 2022, noting that this is still subject to approvals by the province of Ontario. Next slide. The licensing process is a systematic, comprehensive, and transparent process to come to a decision that regulated activities will be conducted safely. It includes significant opportunities for Indigenous consultation and public consultation at different parts of the process. For nuclear power facilities, we have described the entire process in a regulatory document called RegDoc 3.5.1, which can be found on our website. Our regulations require licenses for regulated activities involving preparation of a project site, construction of the facility, and the eventual decommissioning of the facility at the end of its life. We have established license application guides for each phase to explain what information needs to be submitted to support CNSC staff making a licensing recommendation to the Commission. An environmental assessment will be conducted for the entire project lifecycle, and each license will need to confirm how the activities being proposed are meeting environmental protection requirements within the licensee's environmental protection program. Each phase of a project looks not only at the activities that will be performed under that license, but also at the long view. For example, under a license to prepare site, we look at how emergency planning infrastructure and land use planning will be maintained over the entire project lifecycle. Next slide, please. As I mentioned earlier, a licensee is the cornerstone of safety and is held accountable by their license. Any licensing decision by our Commission requires the same ultimate conclusion, which is stated in Section 24 of the Nuclear Safety Control Act. That is, no license may be issued, renewed, amended, or replaced unless, in the opinion of the Commission, the applicant is qualified to carry on the activity that the license will authorize the licensee to carry on, and in carrying on that activity, make adequate provision for the protection of the environment, the health and safety of persons, and the maintenance of national security and measures required to implement international obligations to which Canada has agreed. To come to this conclusion, the Commission requires an applicant to demonstrate using sufficient evidence that these two factors are true in 14 safety and control areas addressed in the licensing process. In a nutshell, safety and control areas, or SCAs, are standardized topics that apply regardless of the type and size of a nuclear power facility project. License application guides are organized around these topics, which we assess during the licensing process. If the applicant is granted a license by the Commission, we will verify compliance and report on performance to the Commission using these topics. If I use an example of one of the safety and control areas shown on the slide, namely security, an applicant is expected to explain how they will establish and maintain both the technological approaches in the plant design processes to ensure a high level of security. This includes making sure the security staff are appropriately qualified. Cybersecurity, for example, is a mix of technology approaches and controls, such as access by personnel to equipment for maintenance. Next slide, please. When CNSC staff assess an applicant's approaches for safety and control area, we act as a challenge function. Request will always be, show me how you are meeting requirements. The discussion will focus on key questions such as, has the applicant established a clear understanding of the potential risks and related uncertainties? What is the safety significance of those risks, and how are they preventing and mitigating those risks? We will ask questions about how the applicant's safety claims are being supported, and we will examine the evidence. Regulatory research activities and talking with other regulators who have looked at these approaches before can and will be leveraged to supplement our work. But beyond technical considerations, Indigenous consultation for a specific project as well as ongoing public consultation will also identify factors that need to be considered in making licensing recommendations to the Commission. Finally, the licensing hearing process itself allows the Commission opportunities to hear from a broad set of stakeholders. This may result in additional factors that the Commission may direct the licensee to consider. But in the end, CNSC can make all the recommendations it needs, but the Commission ultimately makes the decisions. Next slide. Taking one quick step back into what the CNSC staff do when they assess a proposal by an applicant. The requirements and guidance in our regulatory framework always form a starting point for the assessment of the provisions, regardless of the novelty of a technology. We have established requirements and guidance for all of the safety and control area topics. They're based on proven fundamental safety principles that have been adopted all over the world that are as technology neutral as possible. Requirements must be achieved to demonstrate that an appropriate level of safety has been met to a high degree of confidence. Next slide. The obvious question that gets asked is, SMRs represent new technologies, so how do you assess adequacy of the technologies being proposed? Our regulatory framework allows for innovation, but will not allow safety to be compromised. The applicant is required to submit a body of evidence that proves the effectiveness of the technologies in consideration of the people that interface with them. The greater the importance to safety, the higher the burden of proof is required. Where there are technological knowledge gaps, an applicant will be expected to propose ways to compensate for those uncertainties until the gaps in knowledge are sufficiently addressed. They range from things like limits to operation of the facility, more conservatism in the design to address additional testing and inspection of systems, and CNSC staff can also conduct additional compliance oversight of the licensee. CNSC staff are also long aware that there's a lot of public interest in how waste from nuclear power projects will be managed over the long term and how decommissioning of these new types of SMR technologies will proceed. CNSC has recently republished its requirements for radioactive waste management and decommissioning in Canada under a framework for radioactive waste management and decommissioning. And the framework reinforces expectations by the CNSC for upfront planning by vendors and licensees. In our technology reviews, we will actually look at some of the technological approaches that a vendor is considering in their design to actually facilitate more efficient decommissioning and reduction of radioactive waste. And finally, I've left the audience with a number of additional useful CNSC web links on this slide. I would invite everyone to go to the CNSC's website and look around. There's a wealth of information to offer. And I'd like to, we're of course open to answering any questions that you might have after this session.
Wonderful. Thank you so much, Marcel. That brings of our presentations, and we have lots of great questions coming in from the audience members. So we've got about 29 more minutes that we can spend talking and answering questions from the group. But I first just want to say thank you so much to Marcel and John and Dianne for coming and sharing the information today. It's been so wonderful to get this SMR sort of 101 level to kick off this series. We're going to dive deeper in the next 3 sections. And John, when you put up your slide about all of the different companies that have SMR technologies that we're talking about today in Canada, I was really excited because we'll have 9 of those companies actually present specifics about their style and their approaches, the technologies themselves on March 2nd. So that's going to be really exciting for that one. But let's dive into some questions. Dianne, I think I'd love to kick you off with one here. A person, Uduak Akpen from Canadian Nuclear Labs and a PhD research student on SMRs at the University of Alberta, has a great question and asks, as SMRs are being developed for the Canadian energy sector, are end-of-life waste management and disposal considerations also being made? Do you think including this information in our stakeholder engagement would be something that we'd need to do? So maybe, Dianne, I can pass it over to you. And I don't know if Marcel or John, you might want to chat about that as well.
Absolutely, I'm happy to kick us off on this one, and I'm sure both Marcel and John will have more info to add. Candace, I actually have an annex slide that might be helpful to the audience. It's slide number 20 in my deck that could support our discussion on this. The first thing to
pull that up for you, Dianne.
is that great. But I can start addressing the question while you're pulling that up. The first thing to know is the top public policy question that we had in the federal government of Canada when we convened the SMR roadmap in 2018. The project in 2018 was really our analytical piece. In the government of Canada, we saw this wave of innovation, this technology that was being developed, and we had a lot of questions. Are they real? How much are they going to cost? Can they compete on levelized cost of electricity? Kind of waste that we're going to produce, and how are we going to manage that? Is our current plan for a deep geological repository going to meet the needs and be able to deal with these new waste streams? We wanted to know how they're going to be regulated and whether or not our regulator was ready, and we wanted to know the views of Canadians and Indigenous people across Canada. Those were our big questions, and we took 10 months. We did expert analysis. We had expert working groups on these big 5 questions. We had technical workshops across the country, and we had engagement sessions with Canadians and Indigenous people. And we summarized what we heard that is available and still relevant, very much relevant today, at smrroadmap.ca. And so if you want to see more detail than we can provide you in our quick chat today, I encourage you to check out that report. It's very readable. It was meant to be a report out to Canadians on these big questions, including waste. So a couple of things to note. What we learned through that process and what we have been continuing to monitor and ensure is that, number one, our legislation and regulations and standards in Canada for the management of radioactive waste from our existing fleet is sufficient and ready for SMR waste streams. So under Canadian legislation, we have created an organization called the Nuclear Waste Management Organization, and they are mandated in legislation by the federal government to design and implement Canada's plan for the safe long-term management of all used nuclear fuel, not only from our CANDU reactors or research reactors at different campuses, but also future fuel, used fuel from SMRs. The NWMO is working on a deep geological repository. In 2010, they launched a process to identify a willing host community for Canada's deep geological repository, and over 20 voluntarily came forward to be considered as the site of Canada's deep geological repository. Over the course of the next 10 years, there's been this very thoughtful, highly engaged with the communities to sort of whittle down that list and start to identify the most viable and the most likely sites. In 2020, the NWO announced the top 2 sites, and they started digging boreholes to do the geological analysis. So this is a very thoughtful, both scientific process, but also a highly public-facing and engaged process to identify the site. And the site will be selected by 2023. SMR projects, like any nuclear project in Canada, your license from the CNSC, the reactor on, you already have to have an end-of-life cycle plan in place and end-of-life cycle management. So you cannot even turn on your reactor or your SMR and until you have put aside the monies and have the plan for how you're going to, and it will go into our deep geological. And maybe I'll just stop there as well.
Candace, maybe I could just add to, if I could just add to that very quickly. I mean, Dianne has done such a great job of, looking at the very procedural part of this and how safely spent fuel is managed in the plans for the permanent repository. But just a couple of little points of interest that I like bringing up when we talk about waste, which is always top of mind with people who are getting to know nuclear. And the first is how little waste, how little spent fuel nuclear produces. If you can imagine, uranium is 1 million times more energy dense than, let's say, coal. So imagine that. We've been providing 2/3 of Ontario's electricity for more than 60 years, and the amount of spent fuel, because it's so energy dense, would literally only fill up a handful of hockey arenas to the boards. And in the case of small modular reactors, it's a much, much smaller even amount of waste that is produced. Some of the designs are actually fueled in the manufacturing setting and shipped out to site and don't have to be refueled for a decade and in some cases 2 decades. So there's not a lot of activity going along with a lot of these particular technologies. And very exciting, while this is just in the early stages, but a number of the technologies actually use spent fuel from our CANDU reactors as their fuel. So while this isn't a solution for all of the spent fuel produced by the CANDU reactors, and we need the permanent solution, it is an exciting development, which means that some of the spent fuel becomes not only recycled, but a pretty valuable commodity.
Thanks, John. I want to get in. I've noticed it, and I think this is indicative of Alberta. We like to kind of cut to the chase and talk numbers. And so I wanted to tee up. There's a handful of questions that have come in around, tell me about the capital costs of nuclear. How does it compare to renewables, but also for electricity production? But then also, what are the capital costs and the operating costs in an oil sands or an industrial sort of sense? Will it be a technology that is competitive? So I'm hoping maybe John, could you kick us off, and then Dianne or Marcel, if you've got any comments after.
Yeah, so this is the big question, right? And the technology, which is just now being developed and deployed, the numbers are showing that it will be cost competitive with other sources of electricity and heat generation. But the promise of small modular reactors and its ability to deliver on that really is going to have to do with mass manufacturing and deployment, right? So the ability of small modular reactors to hit those promising price points really does mean that we need to see these things deployed at scale. In a similar way to the way that we've seen, you asked about renewables, solar panels and wind turbines come down in cost. It's because of the mass manufacturing side of things. With regard to sort of the operating costs, one of the reasons that the small modular reactors can be economic, in addition to being produced in a manufacturing situation instead of being a large infrastructure project, is because these things essentially many of the technologies do not require human intervention, right? They're fully automated, and they've got enhanced safety features built in as a result of that. So the cap, the ongoing operating costs is very, very much lower than you'd see with conventional plants. So I hope that's a bit of a framing of the cost answer. We're not going to see whether we hit those numbers until we see how nations like Canada and the US and other places do in terms of deploying these things.
Go ahead, Dianne.
I could jump in. I could jump in with a bit more information on this as well. The first thing is I did notice that in the Q&A window of this session, there's a lot of questions. So you're absolutely right. Albertans clearly do want the numbers, because there's a lot of people asking, tell me what the levelized cost of capital costs are. How much are these? So people obviously have an appetite for numbers. So I would recommend Canada's SMR roadmap. So in addition to the action plan, which is smractionplan.ca, please check out Canada's roadmap, which you can find at smrroadmap.ca. And there's a summary report, but there's also, for those who are really interested in the underlying analysis and want to see what the assumptions were for the economic analysis, there's the detailed economics analysis by the working group. But in a nutshell, what I would say is that they have to be proven out, and the costs will come down by deployment of learning by doing. So the cost will come down from that first one that we build. but based on a bunch of very conservative assumptions, because the last thing we wanted to do in the federal government was have rose-colored glasses in the strategic policy framework for these. So we insisted on a series of very conservative assumptions, and in a nutshell, the findings were that SMRs are expected to be cost competitive on the basis of levelized cost of electricity in some, but not all, markets. So, for example, competing with diesel off-grid in Canada is the most cost-competitive market for obvious reasons. And there we could reasonably expect to see 20 to 60% cost savings. The sensitivity about whether it's 20 to 60% depends in part on some of the design features of the SMRs, but in large part on the discount rate, so the cost of capital. For on-grid size SMRs, here we see a range of scenarios where SMRs could be competitive. They are unlikely, so not likely to be competitive on the basis of levelized cost of electricity in a market like where they're competing with large hydro in the province of Quebec. However, in other markets, including in markets like Alberta and Saskatchewan, where SMRs would be competing with natural gas, even with a moderate price on carbon, which was a bit of a surprise to be competitive in some scenarios. The cost analysis, there was also quite a bit of sensitivity analysis around the economies of multiples and how quickly we learn by doing. And there we did some benchmarking against other sectors like shipbuilding and aerospace and other similar types of large modular and we found that the sensitivities in cost were really, the most sensitive factor was cost of fuel. So at a 6% discount rate, they're very competitive in many markets. At a 9% discount rate, the LCOE for SMRs becomes a little bit more challenging. That's just, for those who are really wanting to get into the numbers, if that kind of didn't give you your fix, definitely dive into the economics roadmap report.
Thanks, Dianne. There's a lot of questions around safety, and Marcel, having your presentation about the regulator and the perspective and what needs to happen in Canada to approve technology development and deployment is so appreciated. But folks still are sending in a lot of questions. How safe are these types of technologies in close proximity to communities? There's a similar question about, within the boundaries of large cities. Could these technologies be considered safe enough to participate in, in that remote powered and heat generation, but also in a distributed energy generation? So, Dianne, while we've got you, maybe you could start off and then head over to Marcel for some comments.
Yeah, for sure. So I won't speak long on this one because I really think you should hear from the Canadian Nuclear Safety Commission, and John may also have some perspectives on this. But look, we have collectively as a global community of practice in nuclear, and I mentioned at the beginning that Canada is part of an elite group with the type of scientific and engineering expertise that we have in Canada in nuclear. We have collectively learned a great deal from the last 7 decades of operations, research and development, and that body of experience has informed a number of lessons learned and is really driving a new wave, kind of what we're calling next generation or generation 4 nuclear innovation. So this wave of technologies that's being developed for 2020 30s is next generation technology, and it is taken the lessons learned from those 7 decades of experience, and there's a quantum step, there's a simplification in many of the designs that simplifies the safety parameter. Safety, or you'll hear people talk about intrinsic safety or passive safety, and that's a whole area of work that we can unpack and kind of tease out how the scientists achieve this. But But the bottom line is that they do have dramatically simplified and enhanced safety features, which is what people want. It's what communities want. It's what the operators want, and it's what's really it's one of the main driving forces behind it.
Thanks, Dianne. Maybe Marcel, can we go over to you?
This is Marcel once again from this. Sure. This is one of those subjects where I could probably talk for about an hour, but we'll try to cut it down to 30 seconds or less. Is when a new technology is introduced, we are seeking assurances that the requirements are ultimately met. And what we're looking for instance, is a high degree of certainty that the design will be able to cope with anything that the site and the region will throw at it, whether it is the potential for internal accidents within the plant to things that can hit it from the outside, namely, tsunamis, earthquakes, things like that. We have in the first license normally submitted by an applicant, this is called a license to prepare site. That, plus the environmental assessment, will perform a pretty intensive review of the site conditions that are being chosen. So if a reactor is proposed to be put within city boundaries, we're going to have to understand how that facility will be sufficiently capable of withstanding anything that could come in that could result in a release to the population. And these releases, we seek to eliminate them, and that is built into our regulatory framework. So the licensees are expected to follow a very detailed defense in-depth approach with multiple barriers within the design as well as the way they operate the plants to ensure that there will be no large releases from these facilities. The siting process is usually the best way to choose where a power plant might be sited, and the public will be part of that process, and they'll be able to ask questions of the applicant on how it is that they're ensuring that putting it near a city will result in a sufficient degree of safety. We will not license that facility if it cannot be demonstrated, I might put it bluntly.
Thanks, Marcel. John, did you want to comment at all on the positioning of safety and thoughts around communities?
I don't think so. I think Marcel and Dianne have really covered all bases.
Thanks, John. I think we've got time for a couple of more questions. I did want to link a couple of questions that have come in around, if these sorts of technologies start becoming a reality in Canada, are deployed, what are the transition skill sets that are going to be needed to start seeing these technologies proliferate in different opportunities? How can Albertans prepare? And what kind of timeline do we think we could see technologies like this land in Alberta?
So I can take a first stab at that.
John, do you want to go first?
Yeah, I'll go first. Thanks, Dianne, and then I'll pass it over. So I just want to highlight a couple of the key milestones that we're aiming for as an industry. I think they've been mentioned in Dianne and Marcel's presentations, but we expect that the very small reactors, and so these ones may be 2 megawatts, and they're modular, so they're stackable up to 10 megawatts or something like that. I'm thinking of like a Westinghouse Da Vinci, for example. Industry is targeting to have the first of those deployed by about the 2026 timeline. So that's much closer than many people expect. And of course, Ontario Power Generation has announced that it will connect its first small modular reactor at its Darlington site in 2028. Saskatchewan is going to be following, on its heels. So those give you some general markers in terms of when the first ones are being deployed. There are very active discussions going on right now between the nuclear industry and the oil sands industries. I think Alberta Innovates is playing an important role here, but COSIA in particular is working with our industry, going over the technical requirements now and looking at some of the market requirements, et cetera, et cetera. And so I expect that the oil sands is going to be one of the very first sectors that is going to see these small modular reactors deployed, and I would think with some volume. So we would be looking, I imagine, towards the end of this decade to see some of those units placed in the oil sands. And there's huge potential there. I'll just flag for all of the listeners here that the Canadian Nuclear Association, our organization, is going to be releasing some modeling that has looked at the deployment of small modular reactors in the oil sands. And I think that'll give you a better sense of sort of penetration and timing. So that will be out in the coming days.
So if I could add on to that, first I'd like to actually, I neglected to say the most obvious thing in response to the previous question about safety, which is Canada's safety record. So we have an impeccable safety record. We have 3 of the best nuclear operators in the world here in Canada that are regularly peer reviewed through IAEA, which is the International Atomic Energy Agency, that highest level oversight body that comes in and reviews not only our regulator but the operations at our nuclear power plants regulator. And we have excellent nuclear operators in Canada that have maintained just an extraordinary safety record in Canada. So when I talked about enhanced safety for SMRs, we're really talking about taking a very safe, like empirically proven, very safe track record and bringing it up even more. So I just wanted to make sure I realized after I answered the question that I didn't say the most obvious thing. On this question of what can Albertans do to get involved, and how can Albertans derive the most value in Alberta and create jobs in Alberta for Albertans as the SMR opportunity unfolds, please, all of you should check out Canada's SMR Action Plan. So that's smractionplan.ca, and there you will be able to see all of the. It's a directory of who's who in the SMR space in Canada, and it's an inventory for Canadians and for yourselves of who's doing what on SMRs. And there are a couple key players that I'd like to draw to your attention. The Organization of Canadian Nuclear Industry, OCNI. So that supply chain organization for Canada. And they are running a series of workshops. They've already had one with Saskatchewan, and they're doing work in New Brunswick. To answer the question specifically of how do you retool an existing heavy industry supply chain to help them become part of the nuclear supply chain, because there are some extra requirements if you want to become a nuclear supplier. And I know that the president of that organization would be very interested in speaking with Albertans and Albertan supply chain companies about what it's going to take and how to get there, so that when Alberta is ready to deploy SMRs, you've got some jobs in the supply chain in Alberta. That's one aspect. Another aspect is what John's already mentioned, COSIA, but there are others also. I would encourage you to get in touch with COSIA and also COG, which is the Canadian Can-Do Owners Group. It's a bit of they need a new name because they're more than Can-Do now. They're Can-Do and SMR. So COG is working with COSIA. They have a series of workshops coming up where they're going to be looking at requirements for heavy industry in Alberta. But there's other events that are coming up too, and you can sort of see an accounting of all of this in the action plan. For example, the mayors of some of the key jurisdictions in Saskatchewan and Alberta are going to be having a workshop with the mayors from existing nuclear jurisdictions in Ontario and New Brunswick, where they're going to talk about what does it mean to be a municipality that has nuclear in your respective public. Many things that there's so many ways to get involved and make sure that the needs of Alberta are being factored into decisions that are, and also that there's work being done to make sure that you capture jobs and value in Alberta. So if you check out the website, but at the bottom of the website there's an email address, and you can always just email us and ask us how you can get involved. and tell us about your organization and your interests, and we'll try to match you up with the right players in the action plan team to make sure that this works for Alberta too.
Thank you so much, Dianne. Thank you, John. Thank you, Marcel, for being here today. We've got 1 minute left, and I want to wrap up quickly. So we're going to be continuing this webinar series every week for the next 3 weeks after this, and diving deeper. I noticed so many technical questions coming in about can-do reactors and ramp-up times and pressures and all these sorts of things. Join the session on March 2nd when we've got all of the tech developers to talk about those sorts of things. If you're looking for bright spots and lessons learned and how things are moving and shaking, the folks from the government of New Brunswick Power, Ontario Power Generation, Saskatchewan, government of Saskatchewan, and the innovation centers around there, they're all going to come and talk next week. So there's a great opportunity to dive deeper and continue these conversations. There are going to be resources for you. And so following this, we will send out a link where you can find the webinar recordings, the presentations. We've got reports and links and all kinds of good stuff. If you want to dive deep, we've got information for you. Alberta Innovates has done their own research into opportunities in the oil sands. So if you really want to dive deep there, it will be lots of reading for you to do. So thank you for joining us today. We are out of time, but we will see you next week. Don't forget to register for the next session, and can't wait to talk to you all again soon. Goodbye.